Okay, this is our first review topic of MHF4U1. We're going to review domain and range. Before we do that, though, we're going to remind ourselves what a relation is. A relation is defined as each element X in a set A associated with one or more elements Y in a set B. That means there's a relationship between X's and Y's, and we usually record those as ordered pairs where we have an X and a Y. So for example, we could have the point 1, 4. That means 1 is X and 4 is Y, and the relationship is that 1 gives us 4. A relation is always expressed in terms of X and Y coordinates. The possible values of X and Y coordinates are defined as the domain and range. And if you remember, all of the X's make up the domain. So domain is the set of all possible values of the independent variable X. And range is the same but with the dependent variable Y. The set of all possible values of the dependent variable Y. And the way we write domain and range is, well, there's a couple ways that you'll see it. The way we used it or wrote it in class last year in 11U was we wrote it like this for domain and for range. And that's not on your handout. But if you add it, it reads like for domain, X, ER means X belongs to real. You're defining the number set that X belongs to. And if you remember, there's a bunch of different number sets. And then you state any restrictions. So we say such that, that's what the vertical line means, and then we list restrictions. We're going to work through a few examples. For range, we just do the same, but with Y's. Y belongs to real, such that, and then list your restrictions. So let's work through a couple examples. We have 8, and we'll review how to do domain and range. So one way we can have a relationship expressed is by listing ordered pairs. So our first example A is just a list of ordered pairs, so a list of points. So to write the domain and range when you just have a list of points is you don't have to define the number set or list restrictions. You can just state which values there are because it's much easier to do that. So for domain, we can just say, well, we've got 2, 3, -2, and 1, and if we write them in ascending order, it would be -2, 1, 2, and 4. So our domain is just those numbers. I made a mistake. It's not 4, it's 3. -2, 1, 2, and 3, not 4. There we go, because our x's are the first number. And our y's make up our range. We have 3, 6, 5, and 4. In increasing order, we have 3, 4, 5, and 6. And there we go. Now if you have a graph, we have to look at where the function or relationship is. So in C, we have a graph here. And since we're continuing off the page, we're going to assume that it continues. So for our x's, we have a solid line that covers every x between, looks like -4 and, I don't know, a half. But it continues up and it continues down and to the left, up and to the right. So that means it's going to continue to the right and continue to the left. There's no value of x that this line is not going to take if we continue the graph. So we would just say for domain, x belongs to real, and we wouldn't list any restrictions because there are no restrictions. For our range, we're looking at our y's, and since the relationship goes all the way up and all the way down and covers everything in between, our range is just y belongs to real. Now another way we can be given a function or relationship is an equation. So in B, we're given the equation y equals x squared. Now, that's one of the parent functions that we explored in grade 11, so if you remember the domain and range, great. If you don't, you have to remember what y equals x squared looks like and sketch a picture. So what's y equals x squared? Well, y equals x squared is a parabola, and it's the original parabola with no transformations. So that means it starts at 0, 0, and it goes up like this, and up like that. And if you didn't remember that, you'd have to make a table and graph a couple points to remind yourself what it looks like. Once you have a picture, it's much easier to come up with the domain and range. For domain, we're considering the x's. This graph continues all the way to the left and all the way to the right, and it covers everything in between because we're with a connected curve. So we've got x belongs to real with no restrictions. Range isn't quite the same because we don't have any of the graph extending below the x-axis. Our curve only goes up. The lowest number it gets to is 0. So when we write our range, we can say that y belongs to real, but we have to say that the y's are always greater than or equal to 0, because 0 is the lowest value of y. For D, we have another graph. It's a parabola again, and it continues up. All of our parabolas are always going to have the domain x belongs to real, because our parabola continues left and right and is always connected in the middle. The range is the component that will have a restriction. Y will belong to real, but there's a minimum value of y because our parabola opens up. That minimum value is 2, so we have to say that y is greater than or equal to 2. All right, 4 more, and then that's it for domain and range review. These are all equations, so we have to remember what these equations look like. Now, E and G are both parent functions, so we have to remember what those look like. F is a transformation of a parent function, and H is a function you haven't seen before. So, let's take a shot. Let's take a shot at these. Y equals the square root of x. If you remember what this function looks like, you can sketch it. If you don't, you'll have to make a table of values. Fortunately, I remember what this looks like. It's the one that starts at 0, 0, because the square root of 0 is 0, and curves like this. And that's because, well, you can't take the square root of negative numbers, so we don't have anything over here. The square root of 1 would be 1, so that's 1, 1. The square root of 4 would be 2, so that's 4, 2, and so on and so forth. Once you have a picture, you can write the domain and range. For our domain, x belongs to real, and there's a restriction on x because we don't have any negative values of x. We start at 0 and we get bigger. So x greater than or equal to 0. And for our range, the y's belong to real as well. The y's have to be greater than or equal to, well, 0 is the bottom. We're not going any lower on the graph. So, greater than or equal to 0. What about y equals x cubed? Again, another parent function, but if you don't remember, you'll make a table of values. I'm going to show making a table of values for h, but since g is one of the parent functions in grade 11, we're going to have to assume that you remember it.
Sam Quinn, please dial extension 190. Sam Quinn, please dial extension 190.
And it looks like this and this. And that's because 1 cubed would be 1, but 2 cubed would be 8. Negative 1 cubed would be negative 1. Negative 2 cubed would be negative 8. That's how I can come up or remember those points. 0 cubed is 0, so it goes through 0, 0. And this, for domain and range, actually pretty straightforward. X belongs to real, because we're continuing from left to right, no breaks. And y belongs to real, because we're continuing from bottom to top, no breaks. Just like this line. The only thing that's different is it curves in the middle. F and G. Well, F looks like E, but there's a transformation. And we're going to review transformations in one of the next review lessons. We have to remember, well, this would just be the square root of x function shifted. Do you remember? Left, right, up, down. It's right forward. And we're going to review that in a future lesson. So what would that look like? Well, instead of starting at 0, 0, we'd start at 4, 0, and we'd hook to the right. So what would be the domain and range? Well, we didn't move up or down, so the range stays the same as E. But the domain is now that it has to be bigger than 4.
Ms. Marshall, please dial extension 190.
So x is greater than or equal to 4. Last example. We've got y equals the third root of x. That's a little tricky, so we're going to make a table. X's and y's. So what are some numbers that we can easily take the third root of? Well, we can take the third root of 0. It's 0. We can take the third root of 1. It's 1. And we can take the third root of 8. It's 2. If we work backwards, we can take the third root of negative 1. It's negative 1. And we can take the third root of negative 8. It's negative 2. And if you want to confirm that, you can use a calculator. But now that we have a table, we could just sketch those 5 points, and we should have a pretty good picture of what this looks like. 0, 0, 1, 1, negative 1, negative 1, 8, 2 would be all the way over here, and negative 8, negative 2 would be over here. So we get, kind of looks like the square root function, a little flatter, but it has another side that looks like this. So for domain and range, I'm going to leave that one to you to figure out. It's not super complicated. Check your answer on the course website. The solutions are posted. And that's it for our first lesson, domain and range. There are some practice questions that are associated with this that you should check out and give it a shot, especially if you struggle to remember how to write domain and range. There's some good practice there for you to try. If you feel like you've got a good handle on it, you can move on to the next review lesson, 0.2, function notation. Thanks for watching.